According to the work energy theorem, the work done by the force is equal to the net increase in the kinetic energy of the body. According to the law of conservation of energy, the sum total of energy remains constant. It means energy can't be created nor destroyed, can be transferred from one form to the other. Area under force displacement graph gives the kinetic energy of the particle based on that numericals used to come in exam. The next is an important concept is of elastic potential energy of a spring. It is given by half kx square, where k is the spring constant and x is the displacement or extension of the spring. If the work done against a force is path independent, then the force applied is said to be conservative. If work done is path dependent, then the force is said to be non-conservative. The concept of potential energy is related only to the conservative force, means those force which are not depending on the path. So that will be concerned with the potential energy. The conversion of energy from one form to another is called transformation of energy. Power of an agent is the ratio of total work done by the agent to the time taken by it. It is a scalar quantity. Instantaneous power is the rate of doing work. The absolute units of power in CGS system is ergs per second, and in SI system it is joule per second. It is also known as watt, denoted by capital W. It is after the name of the scientist. The gravitational unit of power in CGS system is gram centimeter per second, and in SI system it is kg meter per second. The popular practical units of power is kilowatt and the horsepower. 1 kilowatt is 1000 watt and 1 horsepower is equal to 746 of watt. This is the third topic of work energy power, that is work energy theorem and the conservation of energy. In that, the first question is, consider a drop of rainwater having mass 1 gram falling from a height of 1 kilometer. It hits the ground with a speed of 50 meter per second. Take the value of acceleration due to gravity constant, and that is 10 meter per second square. The work done by the gravitational force and the resistive force of air is. So this is the options given by A, B, C and D, and this question has come in NEET 2017. It is on the page number 73 of NCERT new. So in this question, this is based on the work energy theorem. According to that, you first understand the concept. Change in kinetic energy. This is equal to the work done by all the forces that are acting there. So the change in kinetic energy denoted by, say, delta Ke, and the work done by the number of forces that are being here are the gravitational force and the resistive force of air. So this is the work done by the gravity plus work done by the air resistance. So if we put the values, the kinetic energy change is given by half mv square. The work done because of the gravity is mgh, and this thing is not given. This we are going to find out. So work because of air resistance is equal to half mv square minus mgh, and m can be taken out common, half v square minus gh. The mass is 1 gram, 10 power minus 3 kg. Velocity is 50 meter per second, and gh, 10 into height is 1 kilometer, 10 power 3. So this is how we can find out the air resistance by solving it. and the value comes out minus 8.75 joule. This negative sign indicates the air resistance. It is in opposite direction. That is why the minus sign is coming. Now, the next part is to find out the gravitational force. The gravitational force, that is W equal to mgh. This value is 10 power minus 3, G is 10, and H is 10 power 3. This is 10 joule. So this is the gravitational force and this is the resistive force. So let us see the options. So we are having 10 joule and minus 8.75 joule as the option, and it goes with the D. 10 joule is our gravitational force and minus 8.75 joule is the resistive force. So the answer for the first part is option D. Question number 2. A block of mass 10 kg moving in x direction with a constant speed of 10 meter per second is subject to retarding force, that is 0.1 x joule per meter during its travel from x is equal to 20 meter to 30 meter. Its final kinetic energy will be, and these are the four options given to us. This is on page number 73 of NCERT New, and this question has come in All India PMT 2013. So let us do question number 2. In this, we need to find out the final kinetic energy. And here we are provided with the work done and we can find out the initial kinetic energy. So, work done is equal to change in kinetic energy. Again, this is based on the work energy theorem. So, work done can also be written as final kinetic energy minus initial kinetic energy, or final kinetic energy is written as work done plus initial kinetic energy. So let us find out the work done. The work done here is force into distance, and that is to be with the limits 20 to 30. Since it is a retarding force, so that is to be taken with the minus sign, and half mv square for the initial kinetic energy, and this value is putting the value of force, that is 0.1 x dx, limit 20 to 30, plus half, mass is 10 kg and speed is 10 meter per second square, so 10 square. Here it will be 5.1 x square by 2, 20 to 30 plus 500. Solving this, we will get it 475 of the joule. So if we look at this, the option number A goes with our solution, and the answer for the second is option number A. Let us see the third question now. The potential energy of a system increases if work is done by the system against a conservative force, by the system against a non-conservative force, upon the system by conservative force, or upon the system by a non-conservative force. This question has come in All India PMT 2011. To answer this question, we have to understand the concept of conservative forces, because when we answer what conservative forces are and how that is going to change potential energy, we can answer this question. So when we are talking about conservative force, they depend only on final and initial position, not on the nature of path. So let us take an example of conservative forces. Here we are talking about potential energy. So we'll take example of gravitation force. The gravitational force is an example of a conservative force. Now, if suppose a body is lying on the surface of Earth and this body is being taken from this to a height, say h, against gravity. So we are doing the work basically against the gravitational force. And when we do it, there is increase in the potential energy. जो ऑप्शंस हमारे पास हैं वो कंजर्वेटिव और नॉन कंजर्वेटिव फोर्सेस का कंसेप्ट यूज करना है हमको, वो कैसे पोटेंशियल एनर्जी को चेंज कर रहे हैं. कंजर्वेटिव फोर्सेस हमारे वो हैं जो सिर्फ एक इनिशियल और फाइनल पोजीशन पर डिपेंड करती हैं. एक क्लोज्ड लूप के लिए वो हमेशा ज़ीरो होते हैं और वो सिर्फ इनिशियल फाइनल पोजीशन पर डिपेंड करने के साथ साथ नेचर ऑफ पाथ पे डिपेंड नहीं करते हैं. और एग्जाम्पल हम लोग ले रहे हैं ग्रेविटेशनल फोर्स. ग्रेविटेशनल फोर्स हमारा कंजर्वेटिव फोर्स है. तो अगर हम लोग एक बॉडी को कंसीडर कर रहे हैं जो कि अर्थ सरफेस पर है, उसको हम अगेंस्ट ग्रेविटी एच हाइट तक लेकर जा रहे हैं, तो वो एक काम हम कर रहे हैं ग्रेविटेशनल फोर्स या कंजर्वेटिव फोर्स और अगेंस्ट दैट. और वो हमेशा क्या कर रहा है, इंक्रीज कर रहा है पोटेंशियल एनर्जी को. इस एग्जांपल से वो चीज़ हमको क्लियर हो रही है. तो इसलिए हमारा ऑप्शन नंबर ए जो है वो करेक्ट है. by the system against a conservative force always increases the potential energy, and I have explained you with an example. So option A is the correct for question number 3. Now the fourth question is, a shell of mass 200 gram is ejected from a gun of mass 4 kg by an explosion that generates 1.05 kilojoule of the energy. The initial velocity of the shell is, and these are the four options given. This question has come in All India PMT 2008. So to find out this, see whatever the things have been given. The mass of shell is 200 gram, that is 0.2 kg, ejected from a gun of mass of gun is 4 kg. Explosion that generates, the energy generated because of explosion is 1.05 into 10 power 3 joule. We need to find out the velocity of shell. Velocity of shell be v, and velocity of gun is, say, v dash. Now we will apply the law of conservation of momentum as well as energy for this, because here we need to find out the velocity of shell. So according to law of conservation of momentum, we have the momentum before the explosion and after explosion should be same. So that will be 4 into v dash plus 0.2 into v, that is equal to 0, because initially there was no momentum. So from here we need to find out the value of v, and according to law of conservation of energy, half 4 v dash square plus half 0.2 v square is equal to 1050 joule of the energy. Now we need to find out the value of v, that is the velocity of shell. This is required value. So we will replace the value of v dash square from this equation, and the value of v dash from this equation is minus 0.2 v by 4. So we'll put the value 0.2 minus 0.2 v by 4 over here. We will have half 4 minus 0.2 v by 4 whole square plus half 0.2 v square. This is equal to 1050, and on solving we get the value of v equal to 100 meter per second. So our option number A is correct for the question number 4. This is 100 meter per second. Here we are taking the topic number 4, power. In that the first question is, two heaters A and B have power rating of 1 kilowatt and 2 kilowatt respectively. These two are first connected in series and then in parallel to a fixed power supply. The ratio of power outputs for these two cases is, and these are the four options given. This question has come in NEET to 2024 last year, and this have been given on the page number 83 of new NCERT. So let us first write down the formulas for the power when the uh, two of the components are connected in series. So the power in series is given by this relation, where say P1 is equal to 1 kilowatt and P2 is 2 kilowatt. It is of heater A and this is of heater B. From here we have the P series is equal to P1 P2 upon P1 plus P2. Mark it as equation number 1. And the equivalent for the power in parallel is simply adding P1 and P2. We have to take the ratio of the power of outputs for these two cases for series to parallel. So P series is to P parallel is given by P1 P2 over P1 plus P2 over P1 plus P2. So this thing is given by P1 P2 over P1 plus P2 whole square. Now P1 into P2 is 1 into 2 and P1 plus P2 is 1 plus 2. So this is 2 upon 3 square 9. So 2 is to 9. P series is to P parallel is equal to 2 is to 9. So our option number B is the correct, and the answer for the first is option B, 2 is to 9. Now the question number 2, at any instant of time t, the displacement of any particle is given by 2t minus 1 in SI unit under the influence of force 5 Newton. The value of instantaneous power in SI unit is, and these four options have been given. Again, this question has come in NEET 2024 and this is on the page number 83 of new NCERT. So to solve this, let us see whatever the things have been given. Here at any time, displacement is given 2t minus 1. force is 5 Newton, and we are supposed to find out the instantaneous power. Now this power in terms of force and displacement is power is force dot velocity. This is the dot product of force and the velocity. So this thing can be written as 5. When we differentiate displacement with respect to time, we will get the velocity. So this value comes out 5 into 2, that is 10. It is in SI. So if we look at the options, our option number A goes with it, and the answer for the second is option A, 10 SI unit. Now question number third, an electric lift with a maximum load of 2000, that is lift plus passenger, is moving with a constant speed of 1.5 meter per second. The frictional force opposing the motion is 3000 Newton. The minimum power delivered by the motor to the lift in watts, you have to take G equal to 10 meter per second square. And these 4 options have been given to us. This question has come in NEET 2022, and this is on the page number 83 of new NCERT. So to find it out, let us first see whatever the things have been given. The mass is 2000 kg. It is moving with a constant speed of 1.5 meter per second, and the frictional force opposing this motion is 3000 Newton. So this is a lift with the passenger that is moving up with the velocity 1.5 meter per second. It is moving in the upward direction, and in the downward direction we are having the weight mg along with the frictional force that is opposing the upward movement. This is the frictional force of 3000 Newton. So this is the tension that is being balanced by this weight and the frictional force. So tension in the lift, this is equal to mg plus the frictional force. So this is given by 2000 into G is to be taken 10 plus 3000 the frictional force. So this value is 23. This will come out 20,000. So this is 23,000 Newton. And the minimum power. So we have got the formula of the power. This is force into velocity, F dot V, or it can be taken as tension in the string. The force and the tension here are same, V. Both tension and the velocity are in the same direction. So cos 0 is 1. So simply tension into velocity. So 23,000 into velocity is 1.5. On multiplying, we get the value 34500. This value will, the power is in watt. So if we look at the options, our option number C goes with it, and the answer for the third is option C. Now it's a question number 4. One coolie takes 1 minute to raise a suitcase through a height of 2 meters. But the second coolie takes 30 seconds to raise the same suitcase to the same height. The powers of 2 coolies are in ratio. 4 options have been given, and this question has come in NEET 2013. So let us first see the formula to find out the ratio. Power is given by work upon time. Now, the work done in both the cases are same because the same suitcase is being taken to the same height. Since the same suitcase is taken to same height, therefore work done by both coolies are same. Let P1 is the power of the first coolie, so work done is equal to time T1, and for the second coolie let it be P2, work done will be same, it is upon T2. Mark it as equation 1 and this as equation number 2. So P1 upon P2 is equal to T2 upon T1. Now the T2 is 30 seconds and the time taken by the first is the 1 minute, that is 60 seconds, and it is 1 upon 2. So P1 is to P2 is equal to 1 is to 2. And the option number D is the correct solution for this. For the answer for fourth is option D, 1 is to 2.